Well, hi there, back again. Here we're in a section that is right angle trigonometry, where prior to that it was unit circle trigonometry. And there's a way of connecting these two, and hopefully you'll see that as we go. So let's get started. 4.3, right angle trigonometry. And you probably remember me inscribing in a circle a right triangle anyway. So it would be very easy to demonstrate that. Anyway, sine, cosine, tangent. As you can see, sine, cosine, tangent. We remember that the letter y, if you're looking at ordered pairs on unit circle, for instance, if you have a circle that looks like this, and let's say you had an ordered pair like this, that point would be x comma y, and we said whatever that point is on a unit circle with a radius 1 would be the x value is the cosine at that angle, and that would be the theta right there, cosine of that theta, and the y would be the sine where the tangent is y over x. And you can see I've got a unit circle, meaning a radius of 1. Here's your x, here's your y. And from here, we ended up getting, from the Pythagorean Theorem, x squared plus y squared is equal to 1, or 1 squared. Just like right here, we'd have a squared plus b squared is equal to c squared. And that's a right triangle right there. So now we've got some phrases for these, we call them functions. Got some phrases. It'll always be a fraction from here on out. The result that you're going to get is always going to be a fraction. And so the numerator is going to be called the opposite side. So here's your angle right here. Its opposite side, it would be directly over here. So you're looking this direction for opposite. And the adjacent is the one that's attached. So opposite side, of course, hypotenuse is always the longest. So sine theta is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. That's the opposite over adjacent, or b over a. That's another way of looking at it if you're looking at the right triangle. Sometimes some textbooks, this is ours, does the same thing. SOHCAHTOA, acronym, sine is opposite over hypotenuse. C for cosine. Cosine is adjacent over hypotenuse. So you can see the letter A and H. You can see the letter A and the letter H, opposite over hypotenuse, and then TOA, tangent, opposite over adjacent. And these phrases right here, I just Googled those, and just another way of like PEMDAS. Remember PEMDAS? PEMDAS in algebra. So please excuse my dear Aunt Sally, SOHCAHTOA. Some of her children are having trouble over algebra. SOHCAHTOA. These are just a couple of them I found just Googling it. And you can probably find some more and make up your own. Okay, so moving ahead here in the next triangle, we've got the theta down here in the bottom right corner, still a right triangle. And by the way, if you're trying to find the side C, you would, and which we're going to need, is going to do the Pythagorean Theorem. And when you do that, you're going to find that it'll yield 5. And by the way, the hypotenuse is never negative on any kind of right triangle. So since I've found all the sides, I can find the 6 trig functions based on theta. So let's start with sine of theta. And again, it's a fraction. It's the ratio of 2 sides. And if I go back up here, if I look at opposite over hypotenuse, O over H, O over H, from here, opposite always looks directionally this way here. So this is opposite. So that would be the number 3. And of course, the hypotenuse is 5. So sine of that angle theta, which more about that later, what the heck is that angle that causes that to be true? We'll be seeing that when we get into the graphing portion, maybe even at 4.4 a little bit, but the graphing portion for sure, 4.5. Cosine of theta is A over H, so adjacent. Now here's theta. If that's opposite, the long side's hypotenuse, this has to be the leftover, which is the adjacent side. So 4 is the adjacent, and hypotenuse again is 5. Okay, tangent of theta. Well, going back up here, tangent of theta is opposite over adjacent. The y over x, but that's y over x is when you got a circle. We don't have a circle, we just have triangles. So let's do opposite over adjacent. That would be opposite over adjacent. 3 is opposite. This is your O in this case. And this is your capital A adjacent. And this is your capital H for hypotenuse. So O is 3 over 4. Now the other 3 trig functions, which are the reciprocals, are easy after you do these. So reciprocal of sine is cosecant. Gosh, if I wanted to do this, I can, but it's just flipping the fractions around. So 5/3. Secant. So secant is the reciprocal of cosine, 5 over 4. And finally, cotangent. 4/3. Okay, flip the page. Let's see what else we got here. Give you another example. Yeah, now we're going to find this side. That's phi. The angle phi, not theta, but phi with a slash through that. And if I need a Pythagorean theorem, I need b squared. So you go a squared plus b squared. So a squared. Okay, 1 squared and I don't know squared. And that would be 5 squared. So what you want to do is solve for b. So b squared is equal to 25, subtract 1. So 24. And b equals plus or minus the square root of 24. But you can't have a negative hypotenuse, so it's going to be a positive. And root 24, there's a perfect square in it, which is 4, meaning 4 times 6. So b equals 2 root 6, 2 root 6. So here we go. We want to find the 6 trig functions. Let's start with sine again. Sine of this phi. Again, it's opposite over hypotenuse. Okay, from phi, opposite is looking this direction. That's opposite. So that would be 1 over the hypotenuse, which is 5. Cosine of phi, adjacent over hypotenuse. Okay, adjacent is 2 root 6 and over 5. And then tangent, tangent phi. Let's see, that would be opposite over adjacent. So opposite is 1 over adjacent is 2 root 6. Now, when you write it this way, most textbooks are going to want you to rationalize the denominator. Now, if you need to do that, you would multiply one idea as root 6 top and bottom. So then what you'd have is, let's say, root 6 all over 2 root 36, which is root 6 over 2 times 6, which is root 6 over 12. And then the reciprocal functions are so much easier. Once I have these, I'll do them up here. Reciprocal of sine would be, again, cosecant of phi. and that would be 5. Reciprocal of cosine is secant, so secant phi, oops, put that c in there. Secant of phi is the reciprocal of this. Okay, now we've got, was that 5 over 2 root 6, which again, if we multiply top and bottom by root 6, you'll have 5 root 6 over 12 eventually, just like I had a 12 down here. And then the last one's tangent. Cotangent, my mistake. So now cotangent is the reciprocal of tangent. And the reciprocal of this, actually I can go over here, the reciprocal of that is just 2 root 6. So 2 root 6. And over 1, but we don't need to write the 1. All right, the next thing is I have this thing called the wheel. It's in your packet. I'm going to show you that. All that is a unit circle that indicates where the angles are. And I'm just looking for cosine being the x and sine being the y. I'm just looking to see what the x and the y values are from the previous section. So let me take a look. Oh, there it is on the previous page. First angle is 60 degrees. I want the cosine of 60. Cosine of 60 degrees. Here it is. And the cosine is the x value. So it's got to be a half. Cosine of 60 degrees is a half. I said a half and I wrote a 6. That was the weirdest thing right there. Okay, half. And to demonstrate that, even with the calculator, remind you on this, you got to make sure you're in degree mode. So here's the mode key right here. See, I'm not in degree mode, I'm in radian. So toggle down here to where the radian is, excuse me, where the degree is, down from radian over degree and highlight that. That's what I'm going to do. And now I'm going to see cosine of the 60 degrees. So cosine, there's a button right here. That's a cosine button. And I'll just type in 60. Now, since I'm in degree mode, I don't have to put a degree marker there. I just do cosine 60, hit enter. It ought to give me 0.5, which it does. All right, 30 degrees. We're still at the cosine, 30 degrees. Right here, cosine is root 3 over 2. Sorry, don't see that. Yeah, 30 degrees, the x value is root 3 over 2. Okay, 45 degrees. Cosine again. So if you go over here, cosine root 2 over 2, there's a 45 degrees, root 2 over 2. That 45 degrees is like this. That's your theta. Okay, root 2 over 2. Okay, pi over 6. Now, pi over 6 is the same value as 30 degrees. Remember how to do that, to convert that? Pi over 6, 30 degrees, you can go over here and see the same thing. Pi over 6, 30 degrees is the same thing. And if it's the sine, it's got to be a half. So 1/2. And if you're going to try to figure that out, see if it's true, get the calculator, you got to make sure you turn that into radians again, because I'm in degrees. Yep, I'm in degrees. So go down here to radians, and I'm going to do sine. Now I have to put in the root or pi divided by 6 down here. See this here, pi divided by 6? So I'm going to put in a little fraction here. I'm going to go pi over 6. Hit enter, 0.5. Yes, it is. Pi over 3. I'll look back up to here. And the sine is root 3 over 2. Remember, this is your x. This is your y. So this here is your sine. So let's say that root 3 over 2. And if you do this one more time, root pi over 4, sine of pi over 4 is also root 2 over 2. The next thing you'll see in this section, they're called cofunction identities. Yeah, if you remember, we did some identities called Pythagorean identities. There were 3 of those. There were reciprocal identities. There were 3 of those. Looks like there's 6 identities here. And all it's saying is if I see the sine of 46 degrees, it's the same as, okay, sine over here, that's 46 degrees. It would be the same as cosine of 90 degrees minus the 46 degrees. So sine of 46 degrees would be the same as whatever this simplifies to. That would be cosine of, let's see, that would be 44 degrees. And just to show you that that's true, I'm going to go in here and got to put degree mode back in again. Okay, here's your degree mode. I'm going to do, I'll do the sine first right here. So sine of 46 degrees. Okay, about 0.719. Cosine of 44 degrees. See if I get the same thing. And I do. With the radians, as you can see, I take 90 degrees for degrees and subtract the angle. That's pretty easy. Otherwise, you got to change radians. Got to make this into, what would this be? Pi over 2. 90 degrees is the same as pi over 2. So cotangent, right here, cotangent, is the same as tangent. Instead of 90 degrees, we're going to go pi over 2, subtract pi over 12. And here you got to get a common denominator, fraction work. Looks like 12. Top and bottom by 6. 6 pi over 12. 6 over 12 is the same as 1 over 2. Pi over 12. So these two are equivalent. Cotangent of pi over 12. Okay, more of the same. If we were face to face, I'd have you just get your wheel out and practice these. And so as I go through, maybe what I'll do is I'll do some of these, maybe even do all of them, because some of them are going to be hard, like the ones like these two right here, for instance. Okay, so here's my thought. If you're going to do any of these funny ones, which is like the cosecant, just ask yourself reciprocals. I'll do this. Think bubble right here. Reciprocal is sine. What's another one here? This one here. Reciprocal of this one would be cosine. Cotangent's an easy one. That's the reciprocal is just tangent. That's an easy one. But here, secant again. So when I look at that, think reciprocal when I find the result on the unit circle. Let's see, that would be cosine. Cotangent's pretty easy. Go down here at the bottom, maybe I'll think bubble right here. This will be sine. Over here, cosine. All right, let's start off with this. Okay, now I'm going to go 45 degrees on the wheel, and I'm going to look for sine, but I have to take the reciprocal of it. So 45 degrees, I'll look for sine. 45 degrees is right here. I'll look for sine, which is the y, but take the reciprocal. So 2 over root 2. 2 over root 2. This is 2 over root 2. Because sine of 45 is root 2 over 2, cosecant is the reciprocal, which would be 2 over root 2. And if you were to rationalize the denominator, that would be 2 root 2 over 2, top and bottom. So you go top and bottom by root 2. Yeah, 2 root 2 over root 4, which is 2. Oh, which is root 2. 5 pi over 6. I'll do this one, then I'll come back to this one. 5 pi over 6. Okay, that's a straight cosine. 5 pi over 6. Okay, there it is right there. Straight cosine is the x value, so negative root 3 over 2. Negative root 3 over 2. Okay, over here. So I'm looking for 60 degrees, but think cosine first, after which I'll take the reciprocal of the answer because it's secant. Look for 60 degrees, think cosine. Cosine is a half. Now take the reciprocal, because secant is the reciprocal of cosine. Take the reciprocal 2 over 1, which is, of course, 2. Okay, tangent. That's an easy one. That's y over x, 5 pi over 3, 5 pi over 3, 5 pi over 3. There it is, 5 pi over 3, y over x, negative root 3 over 2 divided by half. This is negative root 3 over 2 divided by half. And when you take the reciprocal of a fraction, the denominator, notice the 2's will go away. These will go away when you take the reciprocal. So the final answer, negative root 3, is what you'd have. Sine of 30 degrees. This is here. Sine is the y value. So that's a half. Okay, now 90 degrees, now negative 90 degrees. I'm going to look at the tangent, and then I'll take the reciprocal. Okay, remember tangent is y over x. So negative 90 degrees. I have to go this direction for negative. I have to go clockwise. So negative 90 degrees, I'm right here. Here's your x, here's your y. So I've got these two numbers, but if it's going to be the reciprocal, because cotangent, instead of y over x, it's x over y. Again, tangent is y over x, but cotangent is x over y. So I see this as 0 over negative 1, which is 0. Okay, another cotangent, 3 pi over 4, 3 pi over 4, 3 pi over 4. Okay, here it is. Here's your x, here's your y. Tangent is y over x. Cotangent is x over y. These are identically the same, so they'll cancel, and you're left with a negative 1. This is a negative 1. Let me do 9 next. So negative pi. Now I'm going from the standard position. This would be clockwise. This is where it gets me to negative pi. And since it's, I think it was sine, let's see. Yeah, it was sine. It's the y value, so it's got to be 0. So that equals 0. I'm going to hold off on these two for a moment. I'm going to do 3 pi over 4. Since it's secant, I'm thinking the cosine, which is the reciprocal of secant. So cosine of 3 pi over 4, and then take the reciprocal. Cosine of 3 pi over 4 would be the x. Now take the reciprocal. That would be 2 over negative root 2. This would be 2 over negative root 2. Root 2 top and bottom. So that would be 2 root 2 over negative 2, because that's root 4 is 2. So it looks like it's negative root 2 when I'm done. All right, now the last three here. The reason why, let's do this one. This one's not too bad. These two are beyond a revolution. So I want to look at those two in a moment. This one here, negative 270 degrees, negative 270. Don't look at that. That's positive 270. You have to go this way, negative 90, negative 180, and another negative 90. So I'm at this stage right here. And I got to go back and say, oh, it's a cosecant. Do the sine first. Do the sine first. Sine is the y, so it's 1. And then take the reciprocal, so 1. All right, let's do the degrees first. 750. Now, when I do 750, I'm thinking 750 degrees is equal to 360 degrees plus 360 degrees, which is what, 720, plus another 30 degrees. The reason why I'm doing that is I'm going to 2 complete revolutions, and then I'm going to stop at 30 degrees. I'm doing 2 complete revolutions. Okay, so here we go. I'm going to go 360, another 360, 720, and then stop right here. That gets me to 750 degrees. I think that's where we're at, 750 degrees. Now there's a negative here, so I have to include whatever I get as a negative. And since it's cotangent, you know, if you want to think tangent first, which is y over x, tangent is y over x. Tangent is y over x. Then cotangent is the reciprocal, so x over y. So x over y right here, x over y, this over that. So root 3 over 2 divided by half. Don't forget there's still a negative here. Root 3 over 2 divided by half. And the 2's will cancel. The 2's will cancel. When you take the reciprocal of a half, it'll make that 2 go away. So it looks like negative root 3 would be the result. Now, that's a hard one. To check it is hard because you don't have a cotangent button. So I'm just going to trust that it's right. If you ever want to see, I can do it with my calculator, but I do it in front of someone who really wants to see it. And I can demonstrate it that there's a way to check that. But we're going to go with that, trusting that I did it right. And then finally, this last one. Okay, so revolutions. Okay, this is 51 pi's over 6's. I'm thinking, just like here, I went 360. It's a little easy to do with degrees, but I'm thinking 2 pi's revolution. 51 pi over 6 equals. All right, to make a 2 pi with 6's, I'm going to go 6. I need to have, what, 12 pi over 6 is a 2 pi. So 12 of them, I've still got a lot more here to go. Another 12 pi over 6, that's 2 pi, 2 pi. Together, that's 24. Got to do another one. 36, do another one. All right, together, all that's 48 pi's over 6's, and I've got a leftover of 3 pi's over 6's. This is the target, because that's where you're going to stop. This is the same as 2 pi. So you're going to go, looks like 1, 2, 3, 4 revolutions, and stop at 3 pi over 6. Oh, by the way, that's pi over 2. I'm going to stop at pi over 2, which is right here. There. 0, 1, 0, 1. Okay, let's see what we got. We got a, okay, that's a secant. When I see secant, I think cosine. So look at the cosine and take the reciprocal. Look at the cosine. Oh, this was interesting. Look at the cosine. Here's your x. X equals cosine. And take the reciprocal. So if cosine is equal to 0 over 1, then secant is going to be equal to 1 over 0. Do that again, 1 over 0. 1 over 0 is undefined. 0, okay, 0 over 1 is still 0. Take the reciprocal and it's going to be 1 over 0. That's undefined. This is undefined. Undefined. More about that later in the course. What does that mean? Undefined, particularly in the graphing portion. Okay, a few applications. You're going to see in the textbook a few things about angle of elevation. if your eyeballs are looking at the horizon like this, at the horizon, and then you look up, angle of elevation is looking up. The angle of depression is looking down. And there'll be a couple applications, word problems that will do that. We'll see if we, excuse me, got one here that I can take a look at in a moment. Don't worry about this next picture. It's kind of a goofy one, but it shows a bunch of angles. There's no word problem to this. It's just a goofy one. All right, here's one. And if I look at the plane, the angle of elevation would be right here. This is called the angle of elevation, angle, because you're looking up at the plane of elevation. So if I want to find the distance x, which would be the hypotenuse, this is how we're going to end up taking a look at using our trig. Use what you're given, which is 2,500, and the angle 23 degrees. And this is the side I'm looking for, which is the hypotenuse. So this is opposite hypotenuse. Okay, opposite hypotenuse. Okay, what trig function's opposite over hypotenuse? That's the sine. So sine of 23 degrees is equal to the opposite over hypotenuse. That's 2,500 meters divided by x. So simplify this a little bit. This would be sine of 23 degrees equals 2,500 divided by x. A little algebra, multiply this by x, multiply this by x. And then divide both sides by sine 23. Sine 23 degrees is just a number. So x equals 2,500 divided by sine 23 degrees. Now you use your calculator, because 23 degrees is not on the circle. You're just going to use your calculator. Make sure you're in degree mode. I'm going to check that again. Yep. So I need 2,500 divided by sine 23 degrees. And I'm getting, if I round that to the nearest, let's say meter, I'm getting 6,398. 6,000 squiggle, 6,398 meters is the hypotenuse. This right here is equal to 6,398. Certainly longer, that's the longest side, longer than that's height right there. This one, I'm going to come back to in another section. I think in 4.4 is what I want to take a look at it then. So I'll come back to that. I'll even dog ear it right now, but I will come back to it next time. This one here, we want to find the shortest distance from the beach to the point on the island. Okay, island's over here. That's a question mark. Let's make that maybe a variable x, if it's possible. So this one here is going to, I'll just give you a hint. It's going to end up needing two equations, because you won't be able to solve this directly. That's a right triangle, because 50 meters all the way across these two people. I don't know how much that is. And that's a right triangle as well. So the idea might be, let's let this be x from here to there. and this would be the leftover of 50. And now I'm going to create two equations, and well, there are two unknowns, but two equations, and you'll see how I make this work. If I want to find the distance right here, what I'm going to do is, that's x. That should be a different variable. That's not the same distance. Let's make that y. That makes more sense. Yeah, much more sense. All right, so here we go. That's opposite over adjacent. When I hear myself say opposite over adjacent, it's a tangent. So I'm going to take tangent of 30 degrees is the same as opposite over adjacent, x over, well, that's 50 subtract y. And if I look at this angle, 40 degrees, opposite over this adjacent is x over y. And again, that would be tangent. Tangent of the 40 degrees is equal to x over y. And now we're going to do a substitution method. I think I'll take this one and solve for x. So I have y tangent 40 degrees equals x. All I did is just multiply both sides by y. Now I'm going to substitute that in over here to this other equation. This is some algebra techniques that we did in beginning algebra a couple semesters ago. I'm going to take x, I'm trying to narrow it down to one variable. I'm going to take the x, which is y tangent 40, and I'm going to replace it in this fraction. So right here, I'm putting it right there. Now, this is, we need to solve for y on this one. And it gets challenging. The algebra is a little messy, but hey, we can do it. You guys had algebra before, so here we go. I want to get the fraction clean. So I'm going to go 50 subtract y to both sides. And so what I've got is, let's see, tan 30 degrees, parentheses, 50 subtract y equals y tan 40 degrees, because these two pieces cancel. The next trick is to, what I'm going to do is I'm going to go ahead and distribute both sides to tan 30 degrees. So I'll put the 50 out in front first, and that would be tan 30 degrees. Subtract y tan 30 degrees equals y tan 40 degrees. And now I've got the variable y, but they're on opposite sides of the equal sign. So I'm going to move this one over to the right. I'm going to take this and move it to the right. So you get 50 tan 30 degrees is equal to y tan 40 degrees plus the piece that I'm moving to the right, that's where I'm adding y tan 30 degrees. And here comes the trick. Because I got two y's, I'm going to greatest common factor off the y. Greatest common factor off the y. That would be y, parentheses, still have the tan 30 degrees times 50. And now I'm going to divide both sides by this piece because it's multiplied here. So I have y equals, and you got this 50, this piece right here, tan 30 degrees divided by this piece. So what's that going to do for me? Well, it's going to solve for y, which gives me this distance right here. Well, I wanted x, but that's okay. If I got the y, for instance, over here, right here, if I got the y, I can solve for x by just multiplying by tan 40 degrees. So I'm going to find this with my calculator, this piece right here. Zoom in so you can see what I'm going to do and type in. I'm typing in right here. Let's see, I'm going to go fraction. 50 tangent 30 degrees. Should have made sure that I'm in degree mode, but pretty sure I am. Okay, now I'm back over here. And then in the denominator, I'm going to go tan 40 degrees plus tan 30 degrees. And keep my fingers crossed. Here we go. Okay, I get about, let's do 2 decimal places, 20.38. 20.38. But if I want x, which is back up here, here's one place. If I want x, I have to say x equals y tan 40 degrees. I'm going to have to let y be that 20.38, but multiply it by tangent of 40 degrees. Might have been a little easier way of getting it. You'd like to think so. Okay, I'll let you maybe figure that out, but this will work. Again, I'm going to go 20.38 and then tangent 40 degrees. 17.1. So about 17.1 meters. That's the shortest distance from the beach to the island. The shortest distance from the beach to the island. That right there is your 17.1 meters. Okay, one more, I think. Yep, one more. Let's see if there is. Okay, this is the distance the airplane's got to fly to be directly above the tree. All right, so this right here is going to be the angle of depression right here. That's the angle of depression. From the plane to the tree. Okay, if this is 2 miles, how far is this, which is the same distance as this? So I've got to find out what the variable x is. Well, gosh, if I looked at this triangle and I use this angle, 15 degrees, and I went and used 2, what I know I have 2 and I don't know the variable x. That's opposite. This is opposite. And this is adjacent. This is opposite, opposite, and this is ADJ. Sounds like a tangent to me. So tangent of the 15 degrees is opposite 2 miles divided by, I don't know. And then solve for x. This one's a lot easier than the previous problem. Time-wise, looks like I get x tan 15 degrees equals 2, and then x equals 2 over tangent 15 degrees. Calculator. About 7 point, let's go 2 decimal places, 7.46. About 7.46 miles. Okay, and that's all I got in my packet for you today. So until the next time, which we'll take a look at trig functions, just to get a little preview. Trig functions, it's a section 4.4. We'll take a look at that in the next video. But for now, that's all I got for you. All right, see you next time.